This is the first episode in my C++ survival game course. In this course, I'm going to teach you how to use C++ with blueprints in Unreal Engine 5. It's aimed for beginners who have never used C++ before. Now, I really want this series to be a sort of transitioning from blueprints to C++ gateway. I want people who have only ever used blueprints, never touched C++ before, to understand and really get what's going on. In this video, we're going to create this player just running around. I am in the default third person template, but as you can see, this is done with C++. We've gone into Visual Studios, we've written the code. For this video, you don't need any C++ knowledge or minimal. You know, I'm going to explain everything. It's not going to be I'm going to write code and I'm going to tell you it's right and we're going to go on. I'm going to explain what this line does, what this line does, why have we got why have we got this semicolon here, what does saying public actor do here, or a character. I really want to teach you C++ for someone who's only used blueprints, and we will use some blueprints as well, because C++ interfaces with blueprints. You don't just use C++, you don't just type C++ and then it works. You can type C++, then come into your blueprints and then access functions in your blueprints. For example, if I search for look sensitivity, this is a variable that I created in C++. If I can find it here, I created it in C++, but then I can use it in blueprints, and that's the sort of thing we're going to look at. So it's really for, you know a bit about blueprints, you know a bit about the Unreal Engine, but you want to start with C++, you don't know where to start. This is the series for you. We're going to go right from the beginning. We're going to explain everything, starting with simple character movement, and we're going to go into concepts like inventory systems, simple enemy AI. We're not going to go super advanced with the enemies, but crafting is going to be all the default basic survival concepts. And if you have anything you want me specifically to cover, any specific features, we'll do that. Anything you put in the comments, I'll probably make a video on it, where we'll go over how to do it in C++. Without further ado, let's get started with this movement system. So firstly, we're going to open the Unreal Engine, go to third person, and we're going to make a new project. We're going to put it on C++. These settings are fine, you can have them whatever. And I'm going to call this survival game. Now, in this video, I'm expecting that you already have Visual Studios installed. This isn't going to be a tutorial on how to install Visual Studios, because if you don't, there's tons of videos on how to do it if you just go on YouTube. So I'm expecting you've already got Visual Studio set up for Unreal Engine 5. If you do, then you can follow from here. If you don't, stop, go do it. So yeah, let's just create this. Okay, it's loaded. It's probably going to open up Visual Studios. Like for me, it just automatically popped it up. Got these settings here. If you've already set up UE5 with some random tutorial, right, on how to get Visual Studios working, it's very simple. Just follow the tutorial. Just close this. Don't worry about it. In the editor, the first thing we're going to do is we need a class for our character. Normally, right, you go to the content drawer, you go here, you click blueprint class, and then you'd look down here, or you might just press character here, and you'd look for the class you want to use to create our character. Now we're going to do the exact same thing, but first we need to create a class that is going to appear down here, right? We need to have some way to make one of these for ourselves, and then we can come down here and make a blueprint class off of it, because what we do is we make the C++ class, and that in itself isn't actually something we can just spawn into the world. We make the C++ class, which is a base off of which we can then make blueprint classes. So we want to go to the top where it says tools, come down here, press new C++ class, and now we can choose a parent class for this. We're going to make the parent class a character. That just means that when the class is generated, it's going to include some things in the class that, you know, a normal character class should have. Next, we'll call this survival character. all of this path, I mean, just whatever, right? Survival game runtime, public or private, we don't need to touch this. changes nothing for us really, because we're gonna write all the code ourselves. So create class, open Visual Studios. As you can see, a little bit of code is generated for us here, right? This is because we said take from, this is fine, right? Don't worry about this. I'll explain that in just a second, right? I'll explain what it is. So this survival character class, because we said as a character, it's given us this generic include of the character, and that's what that did for us. Now, just then I had that little message pop up, and what happens quite often with the Unreal Engine 5 and Visual Studios is you need to manage which ones open at the same time. If you have the Unreal Editor open and you make some changes, or if you have the Visual Studios open and you make some changes, it can sort of mess with the other one and have some bugs. So throughout this video, if you ever just have like a weird error, the first thing you should do is close Visual Studios, save first, close Visual Studios, close Unreal Engine, then open one of them. That thing that happened just then, it was basically telling me you've opened Visual Studios, but something happened in the Unreal Engine. I know I didn't change anything, but behind the scenes something happened that made a change here, so we had to regenerate the project files to regenerate the change, and that's why if the Unreal Engine would have been closed, that wouldn't have happened. Doesn't mean anything, it's all good. The first thing we're going to do now is I'm just going to talk about what is going on here. What does this code mean? You know, what's going on? But like I said, I'm assuming you have very little or no C++ knowledge. You understand the Unreal Engine, but you might not know anything about C++. So let's get started. First things first, this here, if you press // you can write a comment. And what the comment is, I think it's pretty simple really. It's just code that isn't compiled with the rest of the code, so it doesn't change anything. And here we've got some includes. Now, what an include does, and you can write one by pressing #include, and then either in between two quotation marks or two of these triangle things, you can write it like that as well. It will include, like the name would suggest, code from somewhere else that will be compiled at runtime with your code. Now what that means is here we're saying include game framework character.h. Somewhere between all of these files, right, somewhere, we don't need to know where, but somewhere, there is a file called character.h, right, and it contains loads and loads of code that has a bunch of information about how generic characters are set up. And what the include literally does is when you press compile, which you can do by pressing Control F5, by the way. When you press Control F5, it will compile it and run it. Errors, that's fine. It's because the engine's open and something's changed, right? I know you don't want to hear that, but that is fine. We haven't done any changes. But if it would have run, what would have happened? We wouldn't have seen it, but what happens is that code gets inserted into this line. All the code from character.h is inserted into this line. Same for these ones. So saying include is literally including code from somewhere else into your project. #pragma once, this is a little bit different. What #pragma once does is it just means only run this code once. And you might think that's self-explanatory, like why would you need to say that? Is because this is a header file, and a header file noted by saying .h on the end can be included into lots of other files, but by saying #pragma once only run once, we're just making sure the compiler doesn't run this code loads of times when it doesn't need to. We only run the code once, which isn't guaranteed because it can be included into other files. If you want to know more about including files and default syntax, along with the project files on my Patreon, you can get a cheat sheet which goes into loads of detail about some of these core things that would take 5 minutes to explain. So if you want a little bit more explanation that it goes along right with the video, you can read up on some of these extra topics. Uclass. Uclass is a generic template code. We call it boilerplate code when you just have to write it. It's not super important to fully understand. Well, it kind of is really, but boilerplate code is just when you have to write code because you have to and it doesn't work without it. Uclass tells the Unreal Engine that this is a class specific for the Unreal Engine, right? This is C++. You could write anything. You could say, I don't know, you could call your class, right? Class, whatever. It could be class, I don't know, third person graphics renderer, and you could be making a graphics renderer. And in that case, you wouldn't have Uclass, but because we say Uclass, this means this is specifically a class for the Unreal Engine. And the brackets, that's just because if you have any function, you need brackets, right? Generated body, this is more boilerplate code. You have to have it so the Unreal Engine can do some behind the scenes things to generate necessary code. You have to have the brackets because it's a function, right? You always need brackets for a function. It's just how it is. And then here, right? This is now our class. This is the survival character class. This is the class that we made. This A before the name, you can ignore that. That's just a standard naming convention. It just happens to be there. We didn't make that. When we made the class, it just added it for us. So that's fine. Class survival game API. So first of all, saying class is saying this is a class, right? And then these two curly brackets indicate what is in that class, and the semicolon at the end is there because any line in C++, I guess any logic line in C++ needs a semicolon. This doesn't. You never have semicolons for includes, but at the end of here you do have a semicolon. Here we've got a semicolon, here semicolon, here semicolon. You know, at the end of functions you have semicolons. This doesn't, but like I said, boilerplate code, you can just remember that it's there. You don't really need to know exactly what it does. It just does behind the scenes stuff that need to be done. Survival game API, that is needed because it's like an API, I guess allows, in this case, the engine to know this is an Unreal Engine class, this is part of an Unreal Engine game, do Unreal Engine stuff to it. Because C++ in Unreal Engine is very, very different from general C++. It's essentially a new language. Yes, it has a lot of similar characteristics, but in actual C++, if you wrote begin play, or tick, or float delta time, okay, delta time is actually quite a common thing, but it's not a standalone variable. Well, okay, this is a function input, so that's fine. That's a terrible example. Set up play input component. That means nothing in normal C++, but we only know that this actually does something. All these functions that are Unreal Engine functions only work because we're telling it Uclass, survival game API, generated body, core minimal, all these includes, all these boilerplate code. It's just telling us this is an Unreal Engine class. This is for the Unreal Engine, do Unreal Engine stuff. Okay, now public, protected, and another public. These are access modifiers for the class. Simply, public allows anyone to access these things. Protected allows anyone who's inheriting from the class to access these things. And there's a third one, which we don't have here, but it's called private, and that allows no one to access these variables. So here, protected, right? Virtual begin play. This means that a random class wouldn't be able to go to this class and use the begin play event. But if you made another child of this survival character, if you had like loads of characters and you derived it from here, then this begin play would be accessible in those other classes. These aren't super important. Again, I actually cover this in a lot more detail in the extra reading I've provided with the Patreon, which you can get with just a monthly subscription, $5 for all the project files. But yeah, so these public, protected, and public, just setting up some default functions. Virtual void tick, you'll notice tick, you'll know what it is because it's exactly what it is in blueprints, right? It's, if we go back, if we open a normal character, that's not the character. BP underscore third person character. If I search for event tick, that's where it comes from. Event tick here is coming from tick, right? And you'll actually notice delta seconds. Well, we're passing in delta time, you know. All of these blueprint functions are C++. That's what it is, you know. These functions here, these are C++ code that's been compiled. It's just blocks of C++ code behind the scenes. So yeah, now we've got the the .cpp file. Now, we do have a lot of stuff going on here, but I think not all of it's super important. We already talked about the includes, you know, functions have to have curly brackets, not curly brackets, sorry, these brackets. I first want to talk about what is the link between a C++ file, sorry, a .cpp file and a .h file. .cpp stands for C++ and .h stands for header. Now, they're both C++, you're not writing a different language, they're both C++, but a C++ file and a header file, they're very closely linked, and you have a CPP file and a .h file that correspond to the same thing. So our survival character will always have both. If you made, for example, I don't know, an enemy, you'd have an enemy.cpp, enemy.h. If you made an animal, you might have animal.cpp, animal.h. Any class, you'll have a CPP and a .h, because in the .h file, you are telling the compiler that these things exist. You are forward declaring functions and variables, and forward declaring is basically saying, you know, the compiler is going to come down here, right? It's going to go through this. He's going to come down here. It's going to say, oh, okay, so we've got to begin play. You know, what is begin play? What does it do? Well, here, as you can see, we haven't defined any logic that will happen on begin play. There's nothing. But we are telling the compiler, okay, hello, Mr. Compiler, I promise that there will be a begin play, don't worry about it. Because in CPP, oh, what do you know, we override it. We do begin play, and it's the same for all these functions. You know, if you wanted to make a health variable, you wouldn't do it in the CPP file, you do it in the header file. The way I like to think about it is the header file is for saying, these are the functions we have, these are the variables we have, and the CPP file is for saying, this is what these functions do. If we go back to the Unreal Engine for a second, if we go back to the third person character, you can almost think of it like all the functions, right, on this side, that's kind of just like, you can see the names of the functions, and if you click on it, I know we don't have a function, right, we'll just say tets. You can have input, output, all this information, right, the name of the function, the input, the output, all this description stuff, you can see it in the header file. That's where we declare all that information. But then what that function actually does when we come in here and we say do stuff, that is what's declared inside the CPP file. That's the link between them. Now, you don't technically need one. You could have everything in one file. You could declare this and then actually write the logic for it in the same file. You don't need to have two. It's just standard practice. It's what everyone does. It's what's expected. So that's why I guess it's good to do it. As you can see, it's standard practice because when you get files generated for you, they automatically come like this. Now I feel like, to be fair, the only thing I think that's really important we go over now is functions. Just like what does this syntax do? Syntactically, how is this written? This one's the best example, or maybe this one actually, because it's a bit simpler. Because you can see the input, the logic, and then the function's closed. So how you write a function is the first thing you write is the type of the function. And the type of the function is what the function will return. So I like to go back to here because it makes it quite obvious. If I say return, add a return node, and then let's say I click output, and I have a Boolean variable and I just say true, I don't know, oh, well, we'll put it for success because it's the name, right? Success called true. So we know this function is of type Boolean because it returns a Boolean value. And in our CPP file, that means we would say bool function, and then in here we would write our logic. You always have to have these brackets after test function, because in here, in these functions, let's just say int value, these are variables that are being passed into the function. And then this return value is what's being returned. This bool of the type of the function has nothing to do with the input parameters passed in. The bool is what type is being returned, and void means nothing. Void means we're doing something, but we're not returning any logic. And that's why you can see here, there's no return value because it's a void function, which means we're not actually going to return anything. If this was of type integer, then down here, we might have a return value saying return 1 or return some integer, but we don't have that. All the logic of the function has to be performed within these curly brackets. So you write the type of your function, the name of your function, the input parameters inside brackets, and then afterwards, typically on a new line, you'll write these curly brackets. Now, all throughout this code, you will see that everything is nice and neat. It's on separate lines. Cool. Now, the compiler doesn't actually care that it's on different lines. I could simply get rid of this and just say, well, not those brackets. With these brackets, I could say return true, right? And that is completely correct. There's nothing wrong with this at all. It doesn't have to be in a different line. In fact, I could take this and I could put it there, and that is still correct. It doesn't matter if it's on different lines, it's just it looks better, which is actually very important. There's a lot to be said for it looking more readable, and because when it's more readable, it's more manageable, more scalable, you can better understand what's going on. And that's why it's good to follow these standard practices with these curly brackets. Again, I'd go into a lot more detail in the documents provided on Patreon. One thing I will say before we start, I know I've been talking for quite a while, but I think it's very important you understand these core concepts. Before we start writing code now, I just want to explain one thing. As you can see, when I'm like, well, it was there before, if I just like type something and it'll come up with like, it'll try and guess, see here, it's going to guess what I'm going to try and write. This could be anything, right? If I say void and then something, it's going to try and guess what I'm going to write. The reason that's happening is because I have GitHub Copilot. Now, GitHub Copilot is a completely free extension, and it's already linked into Visual Studios. There's a button up here, you just click on it, and you can log in with your GitHub account, and all of that can be done with just an email account. You don't have to pay for anything, all you need is an email. And what exactly it does is there's a website called GitHub, which is very commonly used amongst coders to submit code and just host projects so you can have them online and other people can download them. And a repository is what one of these things are. When you make a code, right, you're making a repository, which is what everything's stored in. This is a repository, or rather, if I put it onto GitHub, it would be called a repository. And then GitHub Copilot, it looks in all the existing repositories, like all the public ones, you can have them private if you want, and it just sees what code has already been written, and it uses similar code repositories to guess what you're going to write, because a lot of projects will have this very similar code, especially boilerplate code that is just written the same every time because it has to be, like this Uclass. If I didn't have this Uclass and I just started the line by saying I don't know why it's gone there, Uclass, right? It tries to guess that I'm going to say Uclass because it's so common. That's the last thing I want to talk about. Now, we are going to create how we're going to move about, how we're going to jump, and how we're going to look with our camera. All the default movement settings, that's what we're going to do now. Okay, the first thing we're going to do is we're going to add another include in our header file. We're going to say hashtag include survival character, not survival character, input action value.h. That is not spelled right. Include in quotation marks input action. I cannot type today. Input action value.h. This is completely case sensitive. If you say action with a lowercase a, it's not going to work. Everything needs to literally be perfect. So that is a very good reason why you might want to get GitHub Copilot, because it will tell you if it's not right. Also, you get the project files on my Patreon. If you think something's going wrong, you can check and compare with mine, because it's all done for this episode and I know it's working correctly. Now we're gonna make, this is a point. This generated body has just got the squiggly line, so it's telling us something's wrong. What's wrong here? Well, this include in itself is completely correct, but the survival character.generated.h always needs to be the last include. It just does. The line's still there, that's just being weird. But the reason this needs to be the last include, survival character.generated.h, it tells the Unreal Engine 5, or rather it tells the compiler how to do certain things that are needed to work with the Unreal Engine specifically. That's quite vague, because you don't really need to understand what it does. Again, it's just boilerplate code. One of the things it does is garbage collection. And that's a term that basically just means it cleans up loose memory. So if you've, because we're working in C++ and you can incorrectly initialize things, if something is, created and then not destroyed in the right place, or something goes wrong, and for whatever reason, right, you're using, memory that you don't need to be using, it's wasted, this might catch it in the garbage collection and clean it up. But that always needs to be last. Again, just another point you have to remember, because you have to remember it, and that's just how it is. Now, next, we want to have some forward declarations. Before we talked about how these are forward declarations, we're just saying, Mr. Compiler, I promise I'm going to use this. I'm going to say it here, but I'm going to use it in the CPP file. If we didn't forward declare here, when we do it in the C++ file, we would have to declare there, and that's just not how we write things. You could declare it there, but again, like, the whole point of having the .h file is to make it more readable. We need to include some default components that we're going to use to make a character. One of those being the uCamera component. uCamera component. All of these lines need to end in a semicolon, don't forget that. uCamera component, that's just a standard class that's included. You should recognize that from normal, Unreal Engine 5. These aren't random things, right? They're in normal characters. The U spring arm component, we're going to have not the U input component, the U input mapping context. U input mapping context. That's why GitHub Copilot is very nice, because as you see, I just typed in half the line. It guessed correctly what I was going to write, so I can just press tab to fill in the line. I really do recommend getting it. You might think, oh, I can't be bothered, it's 10-15 minutes after I pause the video now and go get my email, but it is really worth it, trust me. It's a game changer. It's really helpful. Now that space was for nothing, just to look nicer. What do we do next? Okay, what we're gonna do now is all of these things we've just, I guess, included, said we've now got access to, because now we can use them. We're going to create variables for these actual things. So saying class uCamera component doesn't actually create a camera for us, but this will. So we're going to go down here, add a comment, and just say components, just to be nice, consistent. And we're going to say, okay, GitHub already guessed for us, UProperty. and then open brackets. And what UProperty does is it's an Unreal Engine specific function. This isn't in normal C++, just when you're using the Unreal Engine. And it's a macro that allows you to do extra things, and it changes slightly how a variable or function is going to work. And it gives it extra behaviors. In this case, some of the behaviors we want to give it is firstly visible anywhere. Visible anywhere. That just means we can see it in C++ and in blueprints. At the beginning of the video, I said you don't just use C++ independently, you interface it with blueprints. It's the best way to go. So visible anywhere. And then the next function we're going to have, or rather input to the function, is blueprint read only. So we can see it anywhere. And now we can read it in blueprints. So when we open blueprints, you know when you go into your character and you can see all these components, that is exactly what we're writing right now. Inside C++, we've said blueprint read only. So now when we are in this code, we will be able to see it, which is exactly what we want. Last one, we're going to give it a category. Category equals camera. This is just to organize things a little bit better. You don't need this. You need the first two, but I don't see why you wouldn't have it. Now that's all the specificities for our variable we're going to make, but that's not the variable itself. The variable is well, okay. Now there's a few we're going to make actually for the camera. We're going to need the camera boom, and we're going to need the follow camera. So we're going to need this line twice because we need two variables. So I'll just say Control-C, Control-V. And then this will apply to the line that's directly underneath it, or to rather the next variable, because I guess you could have a space in between. uCamera component asterisk camera component. I'm just going to move this down because I usually have it as the second one that's initialized. I usually like to initialize first the spring arm component, spring arm component. Now, most of this is self-explanatory. We're creating a variable called spring arm component. This is the name of the variable. It's of type uSpringArm component, which we can use because we've declared it here. But we've got this little asterisk. Now this means that this variable is a pointer. In C++, there's like three types of variables. There's pointers, references, and normal variables. Now this video is really dragging on at this point. I've spent a lot of time explaining things, and I don't want this to last 3 hours. So I'll try and keep this short. When you use a pointer, you aren't storing the variable itself. You are storing a integer value that will point to that variable at a specific location. So imagine you've got imagine memory, right, in your computer is like a hotel, and you've got a bunch of rooms in the hotel, and when you create a variable, right, that variable is sitting in one of the rooms. So you've got the variable is chilling out in one of the rooms. When you have a pointer to the variable, you aren't storing the variable itself, but it's like you're going to reception and you're asking them for the address, for the room number, so the address in memory or in the hotel of that variable. So you go to the room service and you say, what room is this guy in? And they tell you a number, which in computers is always an integer value. And it just says, where is the variable? And the reason we use pointers, so instead of just actually having the variable, but instead having a pointer to the variable, is because if you're passing a variable into different functions, if you're storing it, copying it, duplicating it, whatever, it can be very resource intensive. It can take up a lot of resources and memory, whereas a pointer is very small. It is something, but it's very small. It's a small integer value, which is very cheap. It has very low cost computationally. So that's why we use pointers. References, I'm not going to go into them because we don't have one here, but just so you know, you write them like that, and it's very similar to pointers. They're kind of like pointers with a little bit extra wrapped around them. If you want to know more about them, you can read up on them in the document I've attached with the project files on my Patreon for extra reading and support around the code. It's like 2,000, 3,000 words or something. It took me ages to write that. Anyways, the next property we're going to add, the next variable we're going to add is UProperty. We're going to say edit anywhere. That's how you spell anywhere. Edit anywhere. Blueprint read write. And we're going to say category. Category equals camera. I'm typing really slow because I'm kind of like reaching around my microphone, so it's a bit awkward to type. What we're going to make, I'll explain what these do in just a second. We are going to make a variable. It's going to be of type float called look sensitivity. We're going to set this to 1.0 f because it's a float, and equals whoops, forgot to have the equals. And this is going to be a number that's typically going to be around 1. You might have 0.5 or 1.5, and when we create our function for looking with our camera, where this is going to be a multiplier for, I guess, how quickly we look, and this is edit anywhere, so you can change it in Blueprints, you can read and write to it in Blueprints, and you can just find it. So if we go into our character, when we go into class defaults, it's not going to be here obviously because this isn't our character, but if you searched look sensitivity, this would be here. If we were in our character, our look sensitivity function would be right here, and we'd be able to edit it, change it, do things to it, because we have said blueprint read write, edit anywhere. That's going to be quite nice. Don't need it particularly, but very nice to have. The next thing we're going to add is the movement speed. So UProperty, we're going to say edit defaults only. Edit defaults only. Blueprint read write. Blueprint read write, and category equals movement. All of these inputs, they're very similar. I think at this point I don't need to explain them. It's very much what it sounds like. Blueprint read write, edit defaults only, category, and then this is going to be a float variable or of float type called walk speed of 600.0, not G, F. Semicolon to finish the line, because you always need to finish these lines with a semicolon in C++. These lines don't, because like I said before, when you use Unreal Engine 5, it's like a special type of C++. If you just were using pure C++, it's a lot different. I actually find Unreal Engine C++ is easier than normal C++. Now maybe it's because I've learned C++ first, but I think a lot of people shy away from C++ in Unreal Engine 5 because they think it's a lot harder to learn. But compared to Blueprints, it really only takes like 2 extra weeks probably to get comfortable with it. Maybe 1 week if you're on it every day. It's really not that hard. It is harder than Blueprints, I think, but not hard enough to say no one should even try. And I think a lot of people kind of avoid it. It's harder to get into, but once you're into it, it's definitely a lot better. Next thing I'm gonna add is the default mapping context. So UProperty, we're gonna say edit defaults only. Actually, I'll just copy this line and then tweak it. And instead of saying movement category, we'll put to input. Category of input, we will make the variable U input mapping context. U input mapping context. We're going to make it a pointer of type default mapping context. Cool. The next variable we're going to make is, okay, so these aren't really variables. I mean, they sort of are. We're going to make the input actions. So if you were in the Unreal Engine 5, well, we're still going to do this actually. But you know, you go to your content drawer, and then you might click on here, you might say input action. I'm not going to do it now because I like to have the Unreal Engine closed or Visual Studio's closed when changing the other one. And then that's how you'd see it. We're going to make the input actions here. So we can just copy and paste this. That's got all the information we need. Then we're going to say U input action, move action, copy paste it 2 times. So move action, and then we'll have look action and jump action. Cool. Now we're going to write some functions that we can use these input actions with. So at the top here, under protected, under virtual void begin play override, virtual void override just means that there is already a begin play event in this character. It doesn't have to be in the character, it just in a parent class we've already got this function, but we're going to override it, so we're writing a new one basically. Yeah. We're going to make move, look, jump start, and jump cancelled. So we're going to type void move, const f input action value reference value. So what this is saying is we have a function called move of type void. Now remember, void just means there's no return value. So we're not, you know, when we call this function, we're not giving anything back when it's finished. This function is going to take an input value. This is called value. That just means we're going to store it in a variable called value. All of this is one input. The input is called value. It is of type f input action value, which is a default, you know, UE5 defined type for input action values. It's a reference, I'll touch on that in a second, and it's const. Now what const is it's a promise to the compiler, to not just to Unreal Engine but to the C++ compiler in general, and it is saying when we take this variable as an input, I promise I will not change it. And that means if in our function we try and edit the value that is here, it's not going to work. We're going to get a compiler error and things are going to break, or it won't run, right? It will get an error. The reason we do it is to be very specific and just say, you know, we're not changing it. So someone who's reading the code knows, okay, this function, we're not changing the value. And I guess it just helps stop errors. If you know 100% certain that you're not going to change the value, you should always put const. You don't have to. It goes before the variable. You don't have to have it. The reference, a reference, like I said before, as a pointer, is very similar to a pointer. At its core, it actually is a pointer where it just, you know, instead of storing the variable, it points to the variable. Like if you go to a hotel, instead of having the object that's in a room somewhere, you just have the number to the room so you can go and get it when you need. But in C++, it's sort of like wrapped with extra features that makes it more safe. It just means when you have a reference, first of all, a reference cannot be null. Now that means empty. When you create a pointer, it can be empty, but a reference can never be empty. Otherwise, you just can't have it. It doesn't work. It's impossible for a reference to be empty or invalid. And what this means is if you have a variable, you never ever need to check if it's a reference, if it's valid or not. And that just means it's easier to use. Like with a pointer, you know, if you're doing a bunch of calculations with a pointer, at some point you accidentally might, you know, just break the value that's inside it, or the pointer might point to a different variable to what you think, because you can change where a pointer is pointing to. You can make it point to a different value, but you can't with a reference. A reference always holds the same value. So a reference is basically a pointer that you can never change the value it's pointing to. You can never point it in a different direction, and it always has to be initialized to an actual variable, and it's just safer. That's what we call it. We call it safer. It's safer memory. You don't have to do as much. I guess it's more beginner friendly. Again, if you want to read up more on this, it's all in the document attached on my Patreon. Other than that, let's move on. We're going to create a function, another function called void look with a const input action value called value. We're going to make another function, void, not jump action this time, I'm going to call it jump started, const f input action value as a reference called value, and we're going to say void jump, and let's call it cancelled just to be consistent. Consistent with what you might think? Well, consistent with the notes I've taken out. I've planned out what code I'm going to write, so I just want to make sure it's the same. This isn't the first time I'm writing this code. Jump started, jump cancelled. Now, a green squiggly line basically means this is okay, but it's not optimal. A red squiggly line in theory means this won't run. Now, like I said before, if you have weird errors, sometimes the first thing to do, close your engine, close Visual Studios, reload everything. If I did that, I know this would work. I've done it before, I've run the code before. So in this case, it's fine. Usually you should investigate. But here, this green squiggly line, it means there's a slight problem, but it will run. And the slight problem is that this is a function declaration. We're saying that the function exists, but we're never saying what actually happens when you run the function. So here we've got a bunch of functions, 4 of them. We're saying these exist, but they don't do anything yet, because in our CPP file, now we need to come into our CPP file and say what these functions do exactly. That's the next step. Now in our CPP file, we have a few includes to make. Survival character is the first one, that's already there. This survival character.h is including this header file that we created. That's how these files are linked together, because we're including this file into this one. And like I said before, including literally means when this code is run, all of this code is copied, Control C, Control V, pasted instead of this line. I'm not going to actually do it, but that's how it works. That's how the compiler works. The compiler goes through a few stages when trying to run and like prepare your code to be ran. And one of the things it does, one of the first things it does before it goes into machine code, before it goes into ones and zeros in C++, it will sort all these includes, which is just copying and pasting all of this code. But imagine if you had one file that had all of this code copied and pasted into it, you know, all these files as well, all copied and pasted. You'd have loads of lines of code and it'd just be all messy and hard to navigate. But when you separate it into different files, it's a lot easier to read. So yeah, technically it doesn't run any of it. It's not better for performance, but it's a lot better for maintainability, to read it, to understand it, which in the programming world is extremely important. And you know, even in blueprints, there's certain measures you can take. You can add reroute nodes, you can add comments, you know, you highlight something, press C to comment things. Yeah, so all right, let's get back to it. The next include we want to have is include camera component. There we go. See, because it's a very common setup, I guess, and this is just like a normal setup, it can already guess what we're going to use. Again, game framework spring arm component, that's the next one. We will need an input action, but I'm just doing them in the same order I did them last time, so it just looks easier for debugging on my end. I'm gonna include game framework / character movement component. When you say, that's not spelled right, when you say something / what it's saying is this is the file to go to, and then this is the name of the actual file. So it's like the folder structure. So character movement component.h is an actual file in the game framework folder. So that's like, you could have loads of stuff. You could have like 50 letters, even more. You could have 150 letters typed out here for 10 different folder structures. You can be super specific, but because the people making the engine are very smart, they made it so that it already knows the first part of the include. It's just like going to the folder structure that it needs to go to. The next includes, going to be the enhanced input includes, enhanced input. There's a few of these. We need hashtag include enhanced input component.h, include enhanced input subsystems, this one, hashtag include input action.h, and hashtag include input mapping context.h. It's not super important to understand what exactly each of these includes in itself, because I mean, look how many includes we've got, right? Like even I couldn't tell you exactly what lines of code these break down into. It's just kind of boilerplate code, right? You want to use enhanced inputs, you need to add these, right? Input mapping context, input actions, subsystems, component, more boilerplate code. And I guess that might be why some people think C++ is a bit more scary, because you get big lines of code like this built up. But a lot of the time, it's not that complicated. It's just kind of, it has to be there, so you write it, and sometimes it can look like it's a lot. But when you just try and remember it, it's not that much, especially with GitHub Copilot, when you can just copy in lines like that. So the next include is include game framework play controller.h. Now, can ever tick. This is basically turning on our tick. You could set this to false, and it would mean we're not going to use the tick function, but having it as true means we can use it. This function here is called the constructor, and the constructor, it should be in here as well. As you can see here, a survival character is defined here, or rather declared here, and we define it here. And a constructor is a function. You can pass input parameters as well to it, and it is run as soon as the class is created. It's like as soon as it's created, you run this function, and it's basically the startup logic for the function. So this is like as soon as it's created, we're turning on event tick. That's kind of what's happening here. Now, because this is like the initial startup function, we need to add a few other things. For example, we're going to make a camera boom. So camera boom equals create default sub object spring arm component camera boom. I don't know why I've got 3 U's there. No, not U's, sorry, O's. Camera boom equals create yeah. Okay, so this red squiggly line is because this is the definition of a variable that should have been declared in this character.h. So we should have had a variable already existing called camera boom. Now I don't, because I didn't call this correctly. This shouldn't be called spring arm component, it should be called camera boom. Now you could call it spring arm component, call it whatever you want, but just for consistency, we're going to call it camera boom. If I'd have left that as spring arm component and changed this to spring arm component, it would have worked. It's just this is the camera boom, not the spring arm component. I just must have got a bit confused writing this. And this one as well, I want to make this a bit more obvious. I'm going to call this follow camera, because it's not just a camera component, it's the follow camera. So that's a bit clearer. These are all the declarations of the variables. As you can see, this is the type, this is the name. There's no actual value. We're not saying equals and then something. We're just saying this variable exists. I promise in our CPP, we will tell you exactly what it means. That's what we're doing here. So now we've taken our camera boom variable, create default subobject, which is, create something, right? The something we're creating is a uSpringArm component, camera boom, called camera boom, right? I feel like that line's pretty self-explanatory. Create an object of type camera, uSpringArm component called camera boom. Now we are going to do some things with this camera boom. We're going to set some features. So camera boom, then we're going to do this little arrow because this allows us to access functions through the variable, because this variable is a SpringArm component, so it has a bunch of things it can do. The first thing we're going to do is we're going to say setup attachment root component. And this is just saying attach the camera boom to the root component. So if it's like on our character, which it is, we're saying it's going to be attached to our character because the character is the root component. The next thing we're going to add is the target arm length, which lucky for us is 300f, like GitHub Copilot guessed. Also, GitHub Copilot can do more than just add those things. You can open a chat window. So you can open a chat window and you can ask things here. You can type questions. And what it does, it basically interfaces with ChatGPT. So it'll just like use ChatGPT. So you're basically talking with ChatGPT and you can ask it questions about your code and it can look through your code. So you can say, I have error, blah, blah, blah. Look through my code. Tell me, can you help me fix it? What's wrong? And it can do that. Not always accurate, but if you're in a bit of trouble, can be very nice. Next function, or rather next function to apply, camera boom, B, use pawn control rotation. B tells us that this is going to be a Boolean variable. Use pawn control rotation equals true. That's just like something you'd set up inside blueprints. I don't think I need to explain that. Follow camera. Now we're going to set something on the follow camera, which is why I changed this, because before this was camera component, now it's called follow camera. I could have had both of them as camera component. It doesn't have to be follow camera. That's just what we're naming it. Now, again, this variable is declared, but we haven't actually said what it is. We've said there is a variable, there is a container that is called follow camera, and it's supposed to contain a camera component or a pointer to it, but we haven't given it one yet. So now we're going to give it exactly that. That's correct. Create default subobject, uCamera component text follow camera, create something. That something is a camera component. That camera component is called follow camera. Cool. Now again, we're going to do a little bit of default setup. Is that? Yes, that is correct. Follow camera setup attachment, camera boom, SpringArm component, socket name. So we're saying setup attachment, so like make it attach to something. What are we attaching to? The camera boom. So the camera boom is now like sticking to the camera. It's attached to the camera. It's like, in here how this is like attached to it. It's underneath the camera boom. That's because it's been attached, and that is what we're writing here. We're writing that little drop down where it's attached and is a child of the camera boom. Now, the next thing to change is use pawn control rotation. So yes, that. Set it to false. Camera does not rotate with the arm. It adds the comments as well, because I guess it must be very common that people add this comment. Like I said, all this like text it's trying to type for you, it's basing that off what other people have written in their public available, to just look at code. So obviously a lot of people have written that themselves. Now, camera movement, character movement. Let me think. So because this is a character, and we know it's a character because we made it at the very beginning a child of character, and we're including character here. Because we know it's a character, we can say get character movement. It's a function, so the brackets, even if you don't do anything with them, and as you can see, it's gone yellow, telling us all good. Little arrow, B, orient rotation to movement. We're actually going to have this false. I mean, this isn't a big thing. You could have it as true if you wanted. And again, you'll have come across this if you've used Blueprint, so I don't think I need to explain what that is. We're not going to mess with the control desired rotation. We're going to say get character movement. I can copy and paste that line. Character movement. We're going to change the rotation rate to F rotator, in brackets with a semicolon at the end, 0F 540F and 0. No, that should be point F, 540.F, and this is setting the rotation rate of our character to this value. I guess that's just controlling how quickly our character is rotating. These are 0. The first one is 0 and the last one's 0. Because if you think about it, like your character, it doesn't rotate in all directions, does it? You can like turn on yourself, you can go around in a circle, but you can't like turn into the floor, or I guess turn on the Z value. So it's 540 here because this is how we're turning, like in a circle, like when you turn to look a different direction, that's what that's controlling. But the other ones are 0 because we don't set that. Now the next thing I'm going to set is the walk speed, and we actually made a variable for this over here called walk speed, and here this is quite good. So this is a UProperty variable, which means in our blueprint we can change it, right? We've set some things here, we can change this in our settings. And here, when we say get character movement, max walk speed equals walk speed, because this is happening as the constructor, like I said, this happens as soon as the character is created. This fires, then this fires, so we're setting the walk speed to whatever we set here. And that's how, when we're in blueprints, if we go and we go on class defaults and we say max walk speed and we change it here, as soon as you press begin play, the constructor is going to fire first. It's going to update this value, and then that's how we're going to walk at that speed. And this is what that code looks like behind the scenes, right, on the generic class. The last thing we're going to say B, use controller rotation yaw. Controller rotation yaw equals false, right? That's just a classic thing. Don't think it needs too much explaining. Now we're gonna mess with the begin play. So what do we want to happen as soon as begin play happens? This super begin play is basically overriding the parent's begin play, because this is inherited from the character class, and the character class itself has a begin play function. I guess we're overriding it. So this is gonna, come along with. We are gonna say, okay, so now I'm gonna use some if statements. And if you've never done C++ before, you might not be familiar with how the syntax is written. So I'll just show you real quickly. So you say if, and then you have brackets, and then curly brackets. Pretty simple. So if in this brackets, this is a condition that is being checked by the if. This brackets is what's being checked by the if, and in between these two curly brackets is what's being run if that is true. And then you can also say else if, and then that. And then you can also say else, and it's all really the same idea, right? If, check what's in here, run this. Else if that's not true, check what's in here, then run this. If that still isn't true, if nothing's true and we don't know what to do, we fire this else function that doesn't have an input like check thing, because this is like the default what's fired if nothing else fires. Run this behavior. Okay, and there's actually something quite important about writing ifs like this, which I will touch on in just a second because it's going to help us. When you come to the if statement and you perform a check in here, it actually runs what's being checked. So for example, I'm going to say, and write this as well because this is actually what we need. So a player controller reference PC equals cast inside these brackets a player controller and then to type controller. So here we're checking if our PC is, we're basically checking if our player controller is a player controller, right? This cast is converting our player controller to a controller. I guess this is kind of just a bunch of yap for just saying, is our PC a player controller? But because it's in this brackets, this function actually gets ran. Imagine I had a function in this brackets that like did something, checked something, but it also had a print string. In our game, we would see the print string get run. This actually fires. It isn't like a random check that doesn't fire the function. It does actually fire it, and that's why we can say if this is true, because there's no like check statement here, right? You might think, you know, what does this mean? If what? Okay, if this equals this, but you know, this isn't actually saying if this equals this. This is running a function to set this equal to this, and then it's checking if it's valid. In an if statement, the way to check if something is equal to something, you use two equal statements. So you use double equal sign, and that's how. So if you wanted to have a variable called x, and you wanted to see if it was 5, you could say x equals 5, and that's how you check is x exactly equal 5. But if you say if x equals 5, what you're doing is you're setting your variable called x to 5, and then because it's in an if statement, you're checking if that's true, if that's valid. What that means in this case is we've tried to make our player controller a player controller. So you know in the event graph, right? If I say get player controller, and then I promote this to a variable and call it PC, and then I say is valid, and then imagine right here we've got begin play. This is what we're doing. Okay, so we're getting a player controller, we're setting a variable called PC. This is the type of the variable, this is the name of the variable, this is what it is. A variable called PC that is a player controller is being set to a player controller, right? We're just getting a player controller. And then because it's in an if statement, that is what we're saying when we say is it valid. If we had a double equal sign, this would mean is our player controller exactly equal to this, and that doesn't make sense. That's why it's saying invalid, incorrect, it doesn't work. But we're running this function completely separately. We could have this before the if statement, it's just here because it looks better, and then we're checking if the controller is valid. So this is equal to this. I just wanted to make that distinction because I think that can be quite confusing if you didn't really understand exactly how that worked, because we're going to do it again. The next thing we're going to check is we're going to check our local player input subsystem. So we're going to say if you enhanced input local player subsystem of type pointer. So that's just the type of our variable. We're going to call it subsystem. So we're making a variable of pointer type to this. That's red because we haven't set a value yet. Equals uLocalPlayer double colon, that is the scope resolution operator, and it just means whatever we're going to type after it belongs inside this local player. I'll make that clearer when we finish this line of code. So get subsystem, inside these little triangle brackets, we're going to say U enhanced input local player subsystem, close the brackets, PC get local player, have those brackets, and then have those curly brackets for this. So this line, I imagine if this is the first time you've touched C++, this can look really confusing, but let me explain exactly what we're doing. So we are making a variable called subsystem of type enhanced input local player subsystem, and it's a pointer type, which you don't have, but that's like here we are, okay, we're not actually creating a variable there, but we're creating a subsystem. So we're creating like an input subsystem, which is this, and then we are setting it to this. And what this is a subsystem of type enhanced input local player subsystem, and we're inputting the PC get local player. PC is the variable we made here. We're getting the local player. So we're getting the player controller we made here. We're getting the local player, so it's like saying get player character, and we're giving that to the get subsystem. So here we've got our player character. We're giving it to get subsystem with this as like what type do we want to get. So it's returning the enhanced input local player subsystem for our player character that we find here. That is, we say local player with the scope resolution operator, which is double colon, because the get subsystem function belongs to this. It's just how it is, right? That's just another thing you have to remember, unfortunately. And then we're setting that to the subsystem. So we're getting the subsystem of our local player. That subsystem is of type enhanced input local player subsystem, and we've stored it in a variable. Yeah. The next thing I'm going to do is say if default mapping context, and this is just saying if this is valid. So we could say equals valid. Actually, no, we'd say not equals null pointer. So if our mapping context is not null, so if it is valid, that's the same as this. This is just shorter, more efficient. That's like saying if this is true, if this is valid, if you have an if statement with nothing else in it, if it's true, if it's valid, and then we're going to say need a capital, subsystem, we want that arrow, add mapping context, add mapping context, default mapping context 0. 0 means the first mapping context like that we've got, and we're adding the mapping context to the subsystem we've got, and that is the same as this function right here. So we're getting the player controller, right? Get the player controller, get the player, and then get the enhanced input local player subsystem, get the subsystem, store it in a variable called subsystem, and then in here add mapping context, here add mapping context. Hopefully you can see how what we're doing is the same as blueprints, but this is just written out a bit longer in a bit more code. Okay, now set input player component or player input component. I'm going to move this up here because I want to work on this next, because in my notes this was the next thing I did apparently. We're going to have an if statement, right? So set player component, blah blah blah. So this is just, you know, when this fires, right, what are we going to do? Okay, so if EI comp bind action in brackets, we're gonna say move action. Move action E triggered event triggered this. I'll explain what this means in just a second. Reference to survival character look. Okay, so this, what this means is it's like saying self. In here, if we say get a reference to self, that's basically what it is. Saying this is like saying get a reference to self. It's like this system, this code, this object, this class, this whatever. Okay, so I just realized I took a quick pause in the recording there to check why this was wrong, and I just realized I'm completely stupid. I've just written the wrong line of code. I missed something. So this is a variable, EI comp. This is a variable, but I haven't set the variable. I'm trying to do something with the variable, but I haven't made the variable yet. So that's obviously why that's not going to work, right? So the first thing we need to do is make this a variable. So we want a variable called EI comp. EI comp. This variable is of type enhanced input component, and it's a pointer. So EI comp is going to be our enhanced input component. So we're going to set this variable to I'm going to quickly write out the line of code and then I'll go back and explain it, because it kind of like depends on the other parameters. So just kind of watch what I'm doing and then we'll go through it. I guess that's what I've been doing this entire time, really. UE enhanced input component inside those little triangle brackets. We're casting it to, you know, what are we casting it? Player input component. Okay, so we're making a variable called EI comp of this type, right? Variable name before is the type. We're setting it to enhanced input component. Enhanced input component. It's casting to this from player input component. It doesn't really matter what this is, to be honest. We just need to know that's what type it is, right? We've got our enhanced input component now. So again, because that's in the if statement, and we've only got one equals, we're not checking if this is equal to this. We're setting it to this, and then we're checking if it's true, if it's valid, if you know it's worked. Then we're saying if move action so that's saying if our move action is valid, the move action is what we set somewhere in here. Yes, right here, the move action. I can't show you in blueprints now because we haven't actually got this variable, but imagine we go into our character, we go into defaults, and we search for input mapping context. This is what would come up. This is what we're creating here. We're creating these inputs. So later we will make our input in here. We'll make the input mapping context. We'll create IA underscore jump move look, and then we'll input it into here, and that's what's going to be on ours. It's going to look slightly different because we'll also have the input mapping context to input. We'll make that as well, it's all right. So if the move action is valid, EI comp bind action, move action, triggered this. Yeah, okay, this is right. So bind the action to the action we're putting in this. So what we're saying is if that has an actual input, then every time that is pressed, that is what is going to trigger. We're saying which input event is going to trigger when the move action is pressed. It's like saying, go back to here, go back to the input. These, we're basically binding whatever gets inputted into here, if it's valid, to the action that's going to fire. So when I say IA_jump, we're binding the input to what's going to be fired. That's basically what's going on. Now we need to do that a couple more times because we've got a couple of the functions. If look action, yeah, that's correct. Yeah, that's correct. And if jump, wait, how did I spell jump? This needs to be exactly what the name of this is. So I'll just Control C, Control V from there to make sure it's spelled right. If our jump action is a valid action, if it's true. If it's false, what would it be if it's false? Well, we'll know if it's false because we haven't, imagine we haven't inputted this. We say clear, right? If this is none, this is when that would be false, when it's invalid, when it's null point or whatever you want to call it, and then that would not trigger, right? That is when, if this is empty, that wouldn't trigger. We'll put this back to jump. Go back to our code visual shooters. If jump action, this one's a little bit different. EI comp to the bind action, jump action started this. Yep, bind our jump action. Jump started, EI comp, we called it jump cancel, didn't we? I just want to check. Yes, we did. Jump started, jump cancel. Yeah. So again, this is like saying we're triggering, we're allowing the jump started and the jump cancelled event to fire. Here we created an event called jump started and another one called jump cancelled. We haven't yet said what that does. A little bit further down in this CPP function, in the CPP file, we're going to define what the jump started, jump cancelled functions do, but that's just basically saying, this line is saying, bind the jump action whenever, you know, the space bar's pressed, make this function fire. And we will say what this function does a little bit further down. And now, after 1 hour and 20 minutes of basically just setting things up, we're going to do something that actually does something for us. I mean, all of this does something for us, right? But this is what we're actually going to see because we're going to make the movement. So we're going to say void a. I'm not going to fill that in because I don't want to fill in that much. A survival character scope resolution operator. Move scope resolution operator double colon. We're going to input, we're going to say const f input action value reference called value. This needs to be the same signature as this. That input right there has to be this because before we said we declared this function, we said this function exists. Now we're saying what the function does. The reason we've got this a survival character scope resolution operator is because the scope resolution operator says what scope it belongs to. You know, where is this function coming from? You don't always need it. Sometimes you do, sometimes you don't. And sometimes you can and it's optional, right? But here we need it because we're saying that move is coming specifically from this survival character, which is the character class we created. So I guess it's just kind of specifying that this move function, this one we're saying right here, is specifically from this character class. That's kind of what this little double colon means right there. Now we need our curly brackets, obviously, to say what it does. And we're going to write some logic to say what it does. So I guess this is all, I mean, it's trying to fill it in for me. This is all right. So I'm not going to, okay, you know what? I think it would be easier if no, I'll write it out. I'll write it out with you. So we need f vector 2D, movement vector equals value dot get f vector 2D. What this is doing, making a variable called vector of type f vector 2D, value dot get f vector 2D. So you know when you press WASD on your keyboard, and what that translates to is a value between -1 and 1 on the X and on the Y. So going upwards, you've got -1 down here and 1 up here. So when you press W, you get 1. When you press S, you get -1. If you're like lightly tapping, you can get something in between, or if you're like pressing both of them. A goes to -1 on this side, D goes to -1 on this side if 0 is right in the middle. And what we're doing is we're just getting that value. I'll explain that a little bit more when we actually do the input mapping context in the engine, because I think it's easier to see when you add the modifiers to the input actions, which is just a way to change what's going on. And this, what we're going to say, that's nearly right. So if controller is not equal null pointer, so this is an if statement. If our controller is not equal to null pointer, now a null pointer is just nothing, it's invalid. It's null pointer because we set a lot of things as pointers, and you know how before I said the difference between references and pointers are pointers can be null, references can't. This is kind of where it comes up. Because we used a pointer for our controller, we have to check if it's not null. If this was a reference, you wouldn't have to do that. But when we know it is true, so it is not null, so it's got something in it, we're going to say const f rotator, call it rotation equals controller get controller rotation. So a variable called rotation of type f rotator, which is kind of like just in the graph when you search like rotator and its x and y values and stuff. Constant because we're never going to change it. We're getting it, but we're not going to like set it to something else. Controller get controller rotation. This line is just like when you say get player controller, and then you say, you know, get actor rotation or get control rotation, right? And then you can break that in, you can see what it exactly is. I think if you've done blueprints first, it's quite a lot easier to move over to C++ because you can use blueprints to visualize exactly what's going on in the code. For me, that really helped, just trying to think about what it'd look like in actual code. And a lot of it, you know, you can do that. Const f rotator, your rotator, yes. So setting the rotation, then the your rotation. Again, const because we're not going to change it. Now we're going to say get the forward and right vectors, so we always know where is forward, where's right, which is going to be very helpful when, you know, we want to know which way we're going. So we're going to say const f vector forward direction, you know, variable called forward direction of type f vector. It's a constant. Forward matrix your rotation get unit access blah blah blah. All right, this is yap to basically just find out which is the forward direction. If you really want to go into the specifics of what every little thing does, right, you can get the project files on my Patreon along with the document explaining in more detail what certain things do. But I mean, this is an hour 30, right? If I explain every little thing, we're going to go to 3 hours. I wanted to get this done in like an hour, but that's not happened. So now we're going to do the right direction. So now we know where's forward and where's to the right. I mean, if you think about this on like a graph, I guess it sort of makes sense, right? Like forward X, although to be fair, you'd probably imagine Y as being upwards, so that'd be forward. Anyways, that's kind of just more like boilerplate code, right? But I guess when you've got GitHub Copilot, it fills it in for you. Now, there is a function for us, which is very helpful, like in blueprints, called add movement input. So we can literally just say add movement input forward direction and movement vector dot y, and then we can also say add movement input right direction movement vector dot x. This is exactly what's going on when we set up the walking, and it's not here in 5.5. They used to have the whole function for walking laid out, right? You know, you said like add movement input, and then you had the function over here that was move, and then you plugged in the scale value and you plugged in the direction. That's what's going on here. We're adding the movement input, we're saying what direction by how much, basically. Where we're finding out what direction we're going in, we're finding out how much, and we're just calling the add movement input function to apply that. The next thing we're going to do is the look function. So we're going to say void, I'm going to get rid of this part because we don't need it filled in for now. So void a survival character scope resolution operator to say it's the look from the survival character, const f input action value reference to value. I don't think I need to explain that. I've said it like a million times already. What we're going to do now, we're going to say f vector 2d look axis vector equals value dot get f vector 2d. I think a way I can show you what this actually is, this variable here, which might be helpful. F vector 2d is like when we go into here and we create an input action, no, not that, input action, and you know when you say like what type it is, if I open this up, value type, axis 2d vector is this. So this value here is what we're getting inputted from, you know, this when we have that as axis 2d on the look input action. That's where that value is coming from when we do it, because we're not going to set up the actual input action itself. We can do that in the Unreal Engine editor. We don't need to do that in C++. You know, there's certain things it's easier, better to do. I don't think you can do it in just C++ because it's reliant upon you using that. So we're going to know the if check to make sure controller is not equal to null pointer. So just make sure like we have a player controller. We want to say add controller your input look axis vector dot x times by look sensitivity, which is a variable we created a long time ago, it feels like now, all the way here. And this is blueprint read and write, and it's UProperty, so it's exposed to blueprints. We can change this in blueprints, we can change the look sensitivity, and it's going to be applied to our controller. When I was testing, I found if you just have it as normal, it is a little bit fast, so that's how we can change it. I usually like it on 0.5 for this specific one, but we'll get to that. We'll get to that in like 15 minutes maybe. Add controller pitch input, you know, your input pitch input. This is the same as the blueprint functions, right? Pretty straightforward, I think. The last one we're going to do, and pretty much the last thing we're going to do in C++, I think, is the jump function. Now, so void there we go. So void a survival character, which is just the name of a character, jump started, f input action value. I think that's like a default signature we've seen a lot by now. I won't really get into it. Like in blueprints, you can just call the jump function. In C++, you can just call the jump function, right? We should, for consistency, do a little bit of a if controller is not equal to null pointer. That would be nice, just to make sure everything is done the same. Take that, put that there, and then we want to say void ASL character jump cancelled const, same signature really. If our controller is true, stop jumping. because you say stop jumping. I guess that's just what you do. That's just what's expected. And that should be it. So I'm going to press Control-Shift-S to save everything. We do have some errors, but I am very confident that that is just because the editor's open and it's just, you know, messing with me. I'm going to close the editor. I'm going to just Control-Shift-S to close this. I will Control-Shift-S to close this as well. I just opened back the editor. There's a little cut there, but I didn't do anything, I promise. I just closed the editor, closed Visual Studios, then opened the editor back up. So if I go to our content drawer now, go to C++, guys, it's survival game. Survival game character is the class we created. So double click on that to open Visual Studios again. And then if we look here, there's all this stuff. Should be good. I'm going to press Control B to build. I'll just close that. So it was Control F5 to run, Control B to build. In this case, it doesn't make much of a difference because, okay, I'll address that problem in just a second. In this case, it doesn't make much of a difference because if you press Control F5, it's not like it's going to run the game for you. But if you press Control F5 in like a normal console window, imagine making a calculator, press Control F5, that will build the project and then actually run it. But if you just press build, it will essentially check there's no errors. Now there is an error here, and it just means nothing. Okay, I'm just looking at this. It will still run. Our project will still run. If you're getting an error here as well, and it looks like the same error, don't worry, because to be completely honest, the Visual Studios when using Unreal Engine 5 is very flaky. I found it very commonly says stuff's wrong when it's just not, and I know because I've done this before. Everything's fine here. This will run in our game. This will run. So we go to all content. I'm going to make a new folder, call this mine, just to be, you know, easier to find things, and we create a new blueprint class, and we're going to search for the class we made. So survival game character. So like I said, we created that C++ class. Now we're making a blueprint class based off of it. We're going to say BP underscore survival character. The first thing I'm going to do before doing anything with that is I'm going to go to the game mode, just to make sure we're using that character. So we're going to go to the third person game mode, and you can make your own game mode within C++. That's a thing you can do, and we might actually do that, but for now we're just going to use default one to test it works. So set the default pawn class to BP survival character, compile, save. That's all we need to do there. Now we're going to go off that, go to mine, open the survival character, and now that looks really cool. As you can see, we've got the camera boom, the follow character, the movement, the mesh, the arrow, and the movement were already there because we inherited from a character class, but we made the camera boom and the follow character. If you go on the camera boom, target arm length 400. If we go here to our okay, I've got two of these open because one of them's my test one, and I'm very sure those are the ones that I did before. Like I said, I did this twice, and this is the second time I'm doing it. No, I think this was the other one. Let me open it back up. Okay, so I'll just explain what happened there, because I thought that was because I made another one, and sometimes in Visual Studios it can, like, I don't know, whatever. But this actually could happen to you as well. You might think, what's going on? So our project is called Survival Game, and when you start the Unreal Engine, it will generate a bunch of project files for you automatically. It will generate a character for you because we said third person character. It will generate a third person character, a game mode, and a controller. The name for those classes, for those files, is the name of your project and then character or game mode on the end. So here, Survival Game Character This is the default character class that came with our game, and it's actually very similar to what we made, which is very good. I mean, it's basically the same thing, right? It's controlled a few extra values here. That's fine. But yeah, it's the same. So I thought this was mixing with something else I'd done. It's not. You might see that as well. So if you called your survival game as well and you're calling your character survival character, make sure you look very closely at which one we've just made, because it could be the default one that was generated for you, unless you made it in like a different type of project, but you probably did this third person character like I did. Anyways, as I was saying, yeah, all of this corresponds to what we have just made, which is very, very cool. We didn't set a mesh, but we can do that in Blueprints. Let's give it a mesh, Quinn simple, set it to -88 on the Z and -90 on the Z as well to make it look the right way. If you go to class defaults, let me say look, that's not right. Class defaults, we should be seeing look sensitivity. Why aren't we seeing look sensitivity? Okay, so I literally made the mistake I just told you about. So if you look, this is inherits from survival game character, which is not the character we just made. The character we just made is called survival character, not survival game character. So we inherited from the wrong class. My apologies. I just wasted a few minutes, but I think it's quite important to show that, because you know, when you make a mistake, I think it's important. You're not just like, oh, I'm perfect. Anyways, now we're going to find the right class. So search all classes. We're going to say survival. This time we're going to survival character. Survival. That's definitely not what I made, is it? Okay, so this is just an instance of where C++ and Visual Studios and UE5 has been really weird. There's no problem with what we did. Everything we did was right, and I've just solved it, and I'll show you what I did. So what we wrote in C++ hadn't yet updated into our UE5 project files. Because it wasn't building over here for some weird reason, we hadn't actually seen the update yet, but it has worked. And I pressed this little button down here, which, as it says, recompiles and reloads C++ code for game systems on the fly. So we're making sure what we made is added here. We go to C++ survival game. Now you can see the survival character because it's been builded and added. It's so weird. Sometimes it just doesn't work, sometimes it does. And sometimes you just got to play around with it. It is slower in the sense that sometimes you have to restart your engine. Actually, it's quite often you have to restart your engine. But now everything's working, compiled correctly. All I did, I just pressed that button, and I won't do it again because it'll compile again, but it just compiled and said everything's fine, and then the character showed up. So now if I search here for survival, yes, there it is, survival character. Now it's there because it's been added and it's compiled fine. So now I can say bp underscore survival character, go in here. Now if I search for look sensitivity is there because it is the thing we created. I'm going to put this to 0.5 because I think that suits me better, but I mean, it's not going to break or anything, right? We'll set the mesh to Manny, or Quinn simple, location -88, rotation -90. I'm going to go quite quick. I don't think I need to explain this because this was mainly like a C++ thing, right? We'll use the default input actions because we have them anyways in the class defaults. Scroll down, look for the input actions. Here, default mapping context. We'll create our own mapping context real quick. I'll just search for input mapping context IMC underscore movement. Actually, was there already one called IMC underscore movement? Yes. So will that work? We need an animation as well. Go to the top. I know I'm not really explaining this, but I am just assuming you're okay with it because And what is happening there? Oh, the wrong character. Before we set it as the survival character, now we need to go back to the game mode. Yeah, I'm just assuming you know what to do for this part because it is in blueprints and this was focusing on C++. So default pawn class, we made the wrong one before, we deleted it. Now BP survival character, compile, save. Now, play the game and it's not moving. Great. Okay, we should create our own input mapping context. I was kind of just hoping that one was already set up. I didn't actually know. So let's set up our own input mapping context, which does work and not rely on the default one. We will go to our mine file. We will create a new folder, call it input, move the input here, create an input action. We need ia_move, open that up. It needs to be vector 2D. I'm actually going to rename this to mia_move for my input action because it will come up and say there's already another one called move, the default generated one. So just rename that mia_look. We can duplicate that because the look needs to be accessed vector 2D as well, but the jump, we're gonna have to go in and change this. So mia_jump, my input action jump, change this to a digital bool. We don't need a 2D vector, we just need a are we jumping, are we not jumping. We need to go to our movement, into our input mapping context, add a mapping, and then mia_move, another one, mia_jump. I'll do that real quick, just space bar, and then mia_look. We will say mouse X, and then mouse Y. So we're just getting the mouse X value and the mouse Y value. We need to negate this because it is just not swizzle. We need to negate it, because sometimes it comes with minus values. So like if you look up, it'll look down, and it's kind of weird. Trust me, that's the way it goes. We need WASD. So when you press any like movement keyboard for the move, it will always be, it'll be 1. So if you press W, it's going to be +1 on the X axis, but W is going forwards, so we need +1 on the Y axis. And to go from the X axis to the Y axis, we need to swizzle input axis. That's cool. So if you press D, that's the correct one. That's the one that's already fine. So we press A, we get 1 on the X axis, but we need -1 on the X axis to go left instead of right. So negate, and then S is swizzle and negate because it needs to go down and on the Y axis, sorry. That all should be cool now. And then if you go class default, scroll down to our input mapping context, we search for imc_movement. Oh, that wasn't working because we didn't put any actions before. Huh, probably would have worked. Anyways, we made it ourselves, it's fine. mia_move, mia_look, and mia_jump. We did do a not null pointer check on those, or if valid check on those, I remember. And now we can move around. Cool. My camera's locked. My camera is locked. Let me just check what's going on there. Okay, so the problem is mouse Y here. We need to have swizzle and negate. We need to have both of these on the Y because otherwise it wasn't putting in the value, but now it is moving correctly. Our character's moving weird because we set orient rotation to movement as false. We could easily change that if we just changed our setting in somewhere here. It's one of these settings. It's either this needs to be true or that needs to be false, but that isn't in itself a problem because it's literally one of those settings. Oh no, is this one, this one, this one. This needs to be true. I'm not going to do it because I'd have to save it, recompile the engine, and then load it up again, and it'd literally take like 4 minutes just to show you the change again. But if you change that setting right here, orient rotation movement to true, and then you recompile everything and run it again, then when you press D, your character will actually move to the side rather than just like move that way. So that ain't a problem. That's, I guess, how we've said it. And that is everything. That is, I guess, the first part. I mean, if you want to see more of this, then make sure to let me know in the comments. If you think I explain things too much, let me know. If you want me to go into more detail, I can, although I don't know how I could. You can get the project files for this with all the written code and a document, a few thousand word document which goes into detail about, you know, what's the difference between a C++ and a header file, how do you create functions, the difference between a reference and a pointer, all that kind of stuff. I explain things in a lot of detail just so you can, you know, if I say, oh, we're going to have a pointer here, you can look at it and you can read it and you can be like, okay, that's what a pointer is. It's $5 a month and you get all the project files like that I've ever done. It's everything just under one thing. You download everything. I've done inventory systems, building systems, you name it. done a few. Yeah, so I hope you like this C++ tutorial. If you have any suggestions, let me know in the comments. And yeah, hopefully I'll see you in the next one.